Hello, this is Mr. Gilmore with the 11.3 Part 2, the side-side-side triangle area. So we finish off our area formulas for triangles today by looking at our last case, the side-side-side. Now, I believe the side-side-side really is one of the trickiest cases. We're going to find that we're going to need to make use of our law of cosines to then help tackle the side-side-side case. Now, we've seen really the HL case, the area is equal 1/2 base times height. We've seen the side angle side case and the angle side angle case. But now the side case is really going to need a little bit more ingenuity to it, and then using the side angle side formula, we can find it. However, with the side case, we really have someone to the rescue. Someone actually came and really helped us in finding the area of the side triangle, which we'll talk about here in just a moment. So let's begin with taking a look at a side case. Right now, let's say we consider a triangle here with the sides of 4, 6, and 8. None of the current formulas that we have actually help us tackle this. If we were to drop in altitudes, well, the thing is we don't know any angle measures, so really not much we can do to find the length of that altitude. We don't know then, since we don't know really any angle measures, it's hard for us then to progress through a side case. So really what we'd have to do then is we have to come up with our own technique of finding the area of, or a new technique of finding the area of a side case. And one way to do that is really to use the law of cosines. Now, if you remember, we took law of cosines when we first saw it, which was in a side form, and we adjusted it so that it was in an angle form. So we're actually going to use the angle form to find out, and because we can use the side pattern of a triangle to find one of the missing angles. And then what we can do is, using that missing angle, we can plug it into this side angle side formula, because we'll have an angle, we already have two of the sides given, and so using that we can find in the area of a triangle. So let's go and actually use this law of cosines in addition to the side angle side area formula to find the area of this triangle. So I'm going to go ahead, our triangle 4, 6, and 8 is not labeled. I'm going to label this as A, B, and C. Okay, so I've got my three vertices. I'm going to find the missing measure for angle A. So using our angle form of law of cosines, it looks like this. Angle A is equal to the inverse cosine of A squared minus B squared minus C squared, all divided by 2 times B times C. So our inverse cosine looks like this now. Inverse cosine of 8 squared minus 4 squared minus 6 squared, all divided by negative 2 times 4 times 6. Now, I'm going to evaluate the numerator first. So 8 squared minus 4 squared minus 6 squared, I get a positive 12. And then multiply my denominator, negative 2 times 4 times 6, I get negative 48. Now I can take the inverse cosine of that, which I roughly get the angle measure to be 104.5 degrees. So there's the missing angle measure for angle A. And now if you see, we've got a side angle side pattern. So I can then use the area formula of my side angle side, which is 1/2 side 1 times side 2 times the sine of their included angle alpha. So let's plug in what we know. 1/2 times 4 times 6 times the sine of 104.5, and evaluating that, we roughly get the area to be 11.62. And so there we have it. We found the area of our triangle, but it took a little bit of brute force to, finding out the angle measure and then plugging in our side angle side. We want something a little bit more fluid, to actually find the area of this triangle. So who we have to think is actually an ancient Egyptian mathematician who discovered this for us, and his name was Heron of Alexandria. So of course we accredit this to him as the Heron's formula to finding the area of the side case. Now, before we get into actually looking at this formula, I want to introduce one quick definition to you, because it's going to be used in the derivation of the formula. And it's known as what we call the semi-perimeter. So a semi-perimeter is just really how it sounds. It's half the length of a perimeter, which means if we are given a side case of a triangle, we can actually calculate the perimeter of that triangle by simply just adding the three lengths together. But then a semi-perimeter is half of that. So we'll find the semi-perimeter triangle first, and we'll call that letter S. And we'll see that within our Heron's formula, the letter S is used with the three letters of our triangle ABC. So let's take a look at what Heron dug up for us. So this is the Heron's formula to find find the area of a side-side-side case of a triangle. And again, S represents the so-called semi-perimeter, and A, B, and C are the three side measures of our triangle. So here's what Heron came up with, or here's what he discovered actually for the area of a triangle. The area of a triangle for a side-side-side case is equal to the square root of a product of four things. The first thing is just simply the semi-perimeter. The second thing is the semi-perimeter minus one of our side measures. Let's call that side A. The third thing is the semi-perimeter minus the second side of our triangle. Let's call that side B. And the fourth thing is then the semi-perimeter minus the third side of our triangle, side C. So it's semi-perimeter times the semi-perimeter minus the first side, times the semi-perimeter minus the second side, times the semi-perimeter minus the third side. And that actually then, taking the square root of that, is going to give us the area of a triangle. So then let's actually calculate the area of a triangle using Heron's formula. And in fact, we're going to use that from our exact same triangles before, and we're going to compare our results. So what we first need to do is calculate what the semi-perimeter of our triangle is by simply adding the three sides together, 4 plus 6 plus 8, and then dividing that in 2. So we get 18 divided by 2 is a semi-perimeter of 9. Now, here's one quick check for yourself. The semi-perimeter will always be greater than any of the given sides. If it's not, then you've done something wrong with your semi-perimeter. So take a look. 4, 6, 8, are they all less than 9? Yes, so we're good to go. Now we dive into Heron's formula. So Heron's formula looks like this. It's the square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. It honestly doesn't matter which sides we use, A, B, and C, as long as we use each side exactly once. So I'm going to do the semi-perimeter, which is 9, times the semi-perimeter 9 minus, I'll do my first side as A is 8, times my semi-perimeter of my second side, I'll do, my semi-perimeter 9 minus 6, and then times my semi-perimeter 9 minus 4. So what we end up getting is the square root of 9 times 1 times 3 times 5. Now, what we can get there is if I multiply this through, I can actually simplify this. 9 is a perfect square, which means a 3 pops out. Square root of 9 is just simply 3. And then I have 1 times 3 times 5, which is 15. And I have then the area of my triangle is 3 times the square root of 15. So now what we want to do is actually compare this to our previous area of the triangle. Now we got our previous area of the triangles. Remember, using the law of cosines, and then we added that to our side angle side case. What we got with the area of the triangle to be was roughly 11.62. We now have actually an exact answer for our area formula of a triangle using Heron's formula. This 3 root 15. But if you took 3 times the square root of 15 and plug it in your calculator, guess what you're going to get? You get 11.62. That's roughly 11.62 rounded. So we're going to get the exact same area. But what's nice about Heron's formula is we get the exact area of our triangle. So on your homework assignment for the side-side-side case, you'll take a look at, again, using the law of cosines plus the side angle side case of finding the area of a triangle, and then you'll move on to using this better form, this Heron's formula, where we find the semi-perimeter, and then using Heron's formula, we can calculate the area of a triangle. So please be sure to hop over and take a look at that 11.3 Part 2 worksheet. If you do have any questions on that homework assignment, please do not hesitate to email me. If you do have any questions, right, just I will try to follow up with you as quick as I possibly can. With that, be good and do good.